Welcome to this 10-minute quick webinar with the topic Multi-Angle Detector for 3D X-ray systems of Göpel Electronic. So how does our scanning image acquisition approach lead to shortest image acquisition times in 2D, 2.5D, and 3D? And how can we achieve best test coverage by combining those three technologies? My name is Andreas Türk, and I'm the product manager for the X-ray systems at Göpel Electronic. So let's first start with some basics. In this case here, I have an example of an image capturing chain of one of our AXI systems from the X-line family. And you have the X-ray tube here in the top, which is a sealed type, maintenance-free closed tube. And it has 130 kilovolts. So, but the important thing for today is the detector here below the tube, which is called multi-angle detector and allows you an scanning image acquisition based on multiple bidirectional scanning digital scan lines. And they allow us to have in parallel 2D, 2.5D, and 3D image acquisition. The important thing with this is that the PCB is moved during image acquisition and this detector is standing still. So look at some details. I have a custom example PCB here, and what you see is there are different hidden solder joints on it. With our detector, you can now choose if you want to have a partial inspection of each single component, or if you want to scan the whole board. So both is possible, partial and full area inspection. The typical resolutions that we use are between 10 and 20 micrometers at a field of view size of 46 millimeters till 92 millimeters. The scanning image acquisition allows you to mix up the technologies in your test program. So up to your needs, you can choose if you want to use 2D, 2.5D, and 3D to bring the best test results. So some examples from the field. We have an BGA here, and with the 2D technology, you can do a standard void inspection, for instance, as well as a shortcut inspection. So this is okay if you have a one-side assembled board. Here, 2D is sufficient. If you look at the BGA itself, with a void inside, you will see that the isolation distance here gets smaller and smaller, so also this is measured. Head-in pillow effects or non-wetting effects on BGAs are also inspected using 2.5D or 3D inspection methods. Problems like here, where NVIDIA is taking away the solder from the solder ball, is also inspectable using 2.5D or 3D. QFN inspection, for instance here, non-wetting effects, or here insufficient solder joints, as well as the void detection here in the heatsink is possible with the automated X-ray inspection system. Also solder balls that are not visible using an AOI because it's underneath the plastic body can be inspected with the 2D or 3D X-ray technology. Just imagine this solder ball gets loose. It can make a shortcut. Another example is a connector. Also here, the plastic body sometimes hides the pins or the solder joints of the pins, so you can't see that with an AOI. That's why you have to choose X-ray, either 2.5D in this case here, or also 3D to make an inspection here. Barrel fill inspection on pin and paste or THT solder joints, also possible. In this case here, we can check for barrel fill and also for the voiding and for the volume of those THT solder joints. Another connector examples like here with insufficient pins, also this is testable. Heat sinks in DPACs is testable, and of course some rules acceptability of electronic assemblies are from the IPC 610 and from the 7095. This is a special one for BGA inspection. So why do we need 3D then? So such cases happen in the field. So for instance, an LED inspection, here the vias and the bonding wires interfere with the void inspection. So the result of the void inspection is not good. The same here, microstructures in the printed circuit board interfere with the void. So an inspection is not so easy. That's why you can switch directly into the 3D world. You get rid of the microstructures, rid of vias, rid of bond wires, and you can make a proper void inspection here for this guy. Another example is the LGA. Here you have multiple solder areas. You have one solder area here at the top where the LGA is soldered, a second one on top on the LGA, and a third one here underneath the PCB. So in 2D, you will get crazy because you have an overlap of all the assembly areas. That's why you have to switch to 3D. And in 3D, those signal pins are visible, the ground pins are visible. You can really separate them from the other assembly sites. And also you can go up into the area where the BGA is mounted, which is this one here. So this makes is easier for a 3D inspection system. Also BGA inspection, this is a classic example with double-side assembly and big capacitors on the backside of the BGA. Also here 3D helps us to get rid of those shadow effects and to make a proper inspection of this BGA. By the way, 3D does not only mean that you have one slice available. Typically with our detector, you have a slice thickness of 30 micrometers. You can do multiple slices to make your inspection, and you can do multiple slices to generate such a 3D volume here, like in our CT view visualization. So a void can really be shown up in the volume as a 3D graphic. So effects like head and pillows, voidings, too small or too big balls can be easily visualized with this CT view technology here that is also available on the verification station to make a good decision. No human slip here by helping with the CT view. Another example is the head and pillow inspection. In the CT view, you can see that here our multi-angle detector is always inspecting BGAs at least in three different layers. So one layer close to the pad, one in the middle, and a third one close to the interposer. And we are checking for shape, size, and ratios here to figure out if a ball is lifted or not connected to the pad. In the case of the barrel fill check, you can either work with 2.5D, or if you are also interested in the volume, you can go to the 3D image acquisition and you can get a volume in percent or a volume in cubic micrometers. Of course, also an inspection 2.5D of such pins is possible with our multi-angle detector. So I hope I woke up your interests about our technology. Thanks for your 10 minutes and for your attention. Don't hesitate to raise up questions if you have some. Thank you for your attention.